Hi everyone, welcome back to my channel. In this lesson, we are to learn parallel lines. So in Euclidean geometry, parallel lines are lines in the same plane that never intersect, no matter how far they are extended in either the direction. And in this lesson, we are to learn the relationship in terms of the linear equation. You have your first line as y is equal to m1x plus c1, and you have your second line as y is equal to m2x plus c2. Because the two different lines may show different gradient and y-intercept, so we are to use numbers to differentiate them. So let me talk in terms of their slope first, the gradient. What do you think the relationship between M1 and M2? How do you think of their slope? So the conclusion is that their slope should be equal to each other because they only move in the same speed, the same steepness. They will never reach each other. And your y-intercepts, C1 and C2, must be different. They should cut your y-intercept at different places. So that tells us C1 is not equal to C2. Two y-intercepts are different. Moving on, we are to determine the equation of a line, and that is parallel to this line. So let's rearrange this line in standard slope-intercept form. So I believe if you are to rearrange it nicely, you should have y is equal to minus 3 over 2 x plus 6. And we are to determine the equation of the unknown line. So since the question says that line is parallel to this line, so using the characteristic of the parallel lines, you should have the gradient the same. So your line 2 should have minus 3 over 2. And we are to write the equation in slope-intercept form for our line 2. You have y is equal to m2x plus c2, and we know the value of m2 already. We determined that. And you have y is equal to minus 3 over 2 x plus c2. How would you determine your c2 in this case? The question gave us some additional information that this line 2 passes through this point 4 comma minus 5, and is more like a test point. So let's note the coordinate as x1 comma y1, and in place of x and y in this equation, you are to in place x1 and y1. So you have x as 4 and y as minus 5. And we are now to look at our equation. I believe only your C2 is left unknown. We are to solve this equation, and I believe that should give your C2 as 1 plus 1. Last step, let's rearrange our formula for our line 2. We have y is equal to m2, that is minus 3 over 2 x, and we have plus 1 for our C2. That's the final solution.